The broadcast is now starting. All attendees are in listen-only mode.
I'd like to welcome everyone that's watching our webinar to the new Advanced Logic Database for DProfiler 2013. My name is Doug Maiden and I'm from Beck Technology. I also have Kurt Hansen from Brent Engineering, who has contributed in the mechanical, electrical, and plumbing side of the Advanced Logic Database, which we'll demonstrate today. The agenda for this morning is to, first of all, introduce those that may not be familiar with DProfiler in the latest release, 2012 2.0, what the database was like compared to our new current release, which is 2013 Rev 1.0. In addition to what we're going to focus on, which is the mechanical, electrical, and plumbing side, where you're going to see a sharp contrast between 2012 and 2013, I'd also like to point out a couple of highlights that have been shipped with the product in 2013 that are enhancements to the Advanced Logic Database. Because I have Kurt Hansen here with me, and he has helped graciously helped us with developing the Advanced Logic for the mechanical, electrical, and plumbing, I'd also like him to give us an overview of Brent Engineering and their background and, of course, what he contributes to the database. And then I'll have him wrap up with some rules of thumb and some ways of maybe utilizing your own historic costs rather than what we had actually supplied originally in the 2013 database. So again, for those that may not have seen DProfiler before this time, there was a version prior to what we have right now. In 2012 2.0, we had mechanical, electrical, and plumbing, and there were 3 individual line items, and they were based upon cost per square foot. Now, not exactly terrible as far as being able to get a conceptual estimate. It wasn't very, very accurate. I mean, you'd have to just obviously adjust the unit price per the project itself. So I'm going to go ahead and do a quick demonstration on that. This is DProfiler, and I'm currently connected to the 2012 cost database. So if I select on a new project in 2012, I had the option to create an office 3 to 8 story concrete frame core and shell, an office 3 to 8 story concrete or steel frame core and shell, and of course we have this sample energy analysis option as well. Now I'll just go ahead and use the concrete 3 to 8 story steel concrete frame, select on next, and use a rectangle 4-story office building. Select on next, select just a basic cladding system, and then finish. And I have a project that will have the cost for the mass, the slabs, and the cladding. And again, my focus here today is specifically on the mechanical, electrical, and plumbing numbers. So as I go to the tabular view and then look into my massing, what you'll notice is in my classification scheme along the left-hand side in unit format, as I go down into the D services, I have one single line item, which is my plumbing, at $4 a square foot. I have one single HVAC item, which is $10 a square foot. There is also a fire protection number of the wet pipe system at $1.50 a square foot, and then we have the electrical system at $10 a square foot. Now, Kurt, as you take a look at that, it wasn't bad. It's a starting point for any sort of conceptual estimate. But as we started exploring an Advanced Logic Database, what kind of systems were we really trying to accomplish for an office building?
Sure, and that's going to be based on, that question's based a little bit on the size of the office building, how many floors, the gross square foot of the base floor. There's a lot of variables that came in. So what you'll see as Doug begins to demonstrate some of the new version is that some decisions are being made. There's been some logic that's been applied. The first thing, we started just generic and simple. We started with a rooftop unit or with a small office building that would be served by rooftop units. Typically, we see those buildings anywhere from 1 story up to 4 stories. Above 4 stories, it becomes a little bit difficult to use rooftop units just because the size of the chases going down to serve the first floor get rather large, thus eating up some square footage. So it really, except for special situations, it's really probably not applicable for what we're looking at. Once we get above the 4 stories, we're looking at some alternate type of systems that are going to have some sort of condenser water in them. Those will be your self-contained units, which have the DX electric and the refrigeration cycle all within the unit itself. Rejects the heat to the condenser water system, which goes to then a cooling tower, which will either be up on the roof or down below on grade. Once you get to rather, above, let's say 6 stories, we start moving into either an either-or situation, and from an energy standpoint, you typically default or typically default to a chilled water application, where we'll have a chiller down in the basement or on the first floor. Cooling tower similar to the self-contained units. The cooling tower would be up on either, again, on the first floor or on a low roof, or up on the roof itself of the unit or of the building. But then the actual floors would be served by air handling units that'll have chilled water to them. So those are kind of the 3 different decisions that we had to make on building types and what application would be best for those building types. And as you'll see once Doug starts demonstrating, you could turn certain systems on and off depending when you get into some of those interstitial floors. When you're talking 2 to 4 floors, roof, all options are available. When you're above 6 floors, you've got basically 2 options. That's the self-contained and then the chilled water approach. And then one other thing that we had to talk or think about was the heating of these buildings, and that comes to more of a regional sort of a preference. Down here in Dallas, we're defaulting typically to electric heat. And then once you get above, what we're calling a Mason-Dixon line, which is probably a consumption on the building heat of 40 BTUs or greater per square foot, typically then it starts to make sense to default to a hot water reheat type system for our northern climates.
Fantastic. And that's actually where we, when Kurt and I first started meeting and discussing the mechanical, electrical, and plumbing side to the advanced logic database, we really needed to start to get our arms around, if we just had one number for mechanical, all the variations between a rooftop unit, if it's only 1 to 2 stories, or going to a self-contained unit where it's anywhere between 3 and 6 stories, or maybe even higher, depending upon what the owner requirements are, and then finally kicking into a chiller that might be a better overall solution if you've got a lot of square footage. Obviously, those have a lot of variation in cost compared to what we had, which was one single line item. And of course, then some user always had to know what that unit price needed to be if they were selecting on one system versus another one. Same with the hot water versus the electric. So what I'll go ahead and do is demonstrate the logic that Kurt helped us create in the 2013 cost database. And I'll do this in DProfiler with different building models. I'll come back over to DProfiler. What I first have to do is go ahead and select on the 2013 1.0 sample database connection. This is available to all users that have purchased DProfiler and have upgraded to 2013. There is a little button in the upgrade that allows you to upgrade your databases as well. As you select on that button, you will have this option available to you, or this database connection. As soon as I select on that database connection, I'm now pointing to the new one. So as I go and create a brand new project, my options have changed in my building type. And I only have 2 options at the moment. One is an office building type. The other is a parking garage. I'm going to focus on the office because, again, this is where we can really highlight the mechanical, electrical, and plumbing advanced logic that Kurt has helped us with. As I select on office, I'm going to select on next. And this first pass, I'm going to go ahead, rather than a 4-story building, select on a 2-story number of floors, and then everything else will default as the same. Now in just a moment, when this project is built, you will see we're going to focus on the mechanical, but you'll see that there is a whole lot of additional cost items that have also applied to the building mass. In the previous one, I probably had about 28 line items on the building mass, and in just a moment when my building finally comes up, I believe you'll see about 100 and a little over 100 line items in the building massing. So as I come over to my building mass, I'll go ahead down here. Actually, my number is a little bit incorrect. I actually have potentially up to 250 line items in in this building mass. Now, many of these items will not be turned on because they are based upon the systems that are going to be applied in the building as well. At the moment, you'll see that we do have an electrical set of costs, and we'll go in and take a look at that. The real key indicator here, because it's a two-story building, as Kurt had mentioned, would be quite beneficial to have a rooftop system. So it has automatically elected to default to the rooftop system. We do have some common mechanical systems or common mechanical items that are shared between all systems. And then we do have a plumbing set of items as well, and I'll go ahead and drill down into them as well. Now, I do have, and this is just on a side note, other items in the building massing, such as core items for interiors. We do have the fire protection, passenger elevators, stairs, freight elevators, and some building envelope that has also been included, which is a lot greater detail than what was in 2012. But again, to stay on topic and focus with the mechanical, electrical, and plumbing, we'll go ahead and take a look at what has been generated by selecting on a two-story office building. Let's first of all go to electrical, and as I go into this electrical collection, you'll notice that I have a total of 17 items of cost now, and I look at that number down here in the lower left corner. You can see how many items are being triggered inside of this collection. You can see they're all turned on. So rather than, I believe we had, was it $10 in cost for the electrical cost per square foot, we are now accounting for items in greater detail, and we can see these 17 items. I do have the ability to take a look at what the overall cost per square foot is. Well, actually I can see what the total cost of the project is. So if I just sum that up, we've got $945,550 contributing in the electrical. Probably have to divide that out by the gross, and of course I could create a formula that would tell me what that is, cost per square foot. But this is relevant to the two-story office building. Now, many of these numbers at the moment are based upon gross square footage of building area, and we are working in another version, kind of a maybe a 2014 release, where we're working with Brandt Engineering and their electrical engineer to take a look at the logic that we've embedded in the mechanical side, and as we choose different systems such as the rooftop, the scud, or the chiller, we will also vary the electrical consumption based on that as well. I'll go ahead and back out and also point out to everyone before we get to the mechanical that, again, fire protection has been a little bit more embellished than before. So now we have a couple of systems or a couple of line items in place, and then there's some options whether or not we need to have the additional equipment added in, and these are user-defined options whether or not whether you need to make sure that you're including additional costs. One other one before we go to specifically onto the mechanical is that the plumbing has been also increased from one line item up to now we have 24 items, and then some of these are not having a cost applied at the moment, and that is because that there are other systems in play or rooms that have been defined that are also accounting for those costs. Now, the real logic is in the mechanical system. As Kurt had mentioned before, we selected rooftop systems for 2 to 4 story office buildings. Above maybe 2 stories, we start to consider the self-contained, and above 6, we start considering the chiller. You'll notice at the moment the rooftop system has been selected, and as I go down into this rooftop system, you will see that there are several items of cost here as well. I select on one of the row headers, and I can see that there are 10 items when we default to a rooftop system that potentially will have cost. Now, some of these do not have costs associated with them based upon whether the heating option has been turned on. Now, I'm going to go ahead and close out of my tabular view and then generate a second model to compare this building next to a building that is 3 stories. So I'll go to All Systems and then over to the wizard, and rather than a 2-story building, I'm now going to select 3 stories, and then everything else is the same. Now, as I place my 3-story building, you'll notice in just a moment after it has been generated, it will automatically select a different system based upon square footage and number of floors. So now as I go over to the tab of the view, I'll minimize my two-story building, look at the three-story building, and here I still have my electrical collection, I still have the fire protection and the plumbing, but the significant part here is because of the number of floors and because of the square footage, we've now elected to go with a self-contained unit. Now as I select on the self-contained unit, you can see a total of 10 items of cost. Again, not all of them are going to be turned on based upon whether or not the heating requirements are required. Here, a little bit later, you'll notice that when we go north of, say, the Mason-Dixon line and we need to have more heating requirements, we will turn on a boiler automatically, and then once a boiler exists, we do have the option to also allow the VAV boxes at the perimeter to be heated by that hot water. I'll go ahead and close back out of my second building and then come back to the spatial view and create one last building. This is going to be, again, a building wizard. I'll go to the 4-story, select next, next, and then finish, and place my 4-story building down. And again, based upon the number of floors and the square footage, we will determine what is the best mechanical system to select for pricing.
One quick item that we could note at this point, Doug, is that on that 3-story building, if you instead wanted to elect to go to a rooftop unit, let's say that was being driven that way by the owner, you would still be able to override that and make that selection and get the costing elements put into your model from the rooftop unit selection versus the default SCUD selection.
Perfect. Exactly. So we do have automation to determine rooftop versus SCUD versus chiller, but there are manual overrides so that 3-story, and I'll do that in just a moment, where the 3-story could be a rooftop system, or it could even go to a chiller, though that might not be a very cost-effective arrangement, but I'd like to chat with you a little bit more and see are those options, but at least they're available. When it comes to the 4-story, this building automatically then determines that the most appropriate mechanical system for our project is the chiller system. And this was done simply by, again, the number of floors and the square footage. Of course, as Kurt mentioned, we do have the ability to manually override these. So at the moment, it has been selected as a chiller, and we're at $1.8 million for a chiller system. I can go over to my contributing variables, and I can take a look at the different variables that are in play that allow me to decide which type of mechanical system I would like. I have the user-defined variable here, which is mechanical system. You will notice at the moment a value is set to 3. 3 means that it has automatically been selected. So all 3 of our buildings, whether it's the 2-story, the 3-story, or the 4-story, have automatically been selected to their most appropriate mechanical system that we have chosen over looking at historical numbers and various projects. Now, as Kurt had mentioned, I can go ahead on this 4-story and say that I would like to take it down to, say, for example, a self-contained unit. So if I select on 0, pressing enter, in just a second I can go over to my collections again and now notice that a self-contained unit is now in play rather than the chiller system, and you can see that we have savings of around, say, $200,000 on our project because we're now down to $1.6 million. And of course, that self-contained system does contain those same items that everyone did see a little earlier when I was looking at the 3-story building. So we have 10 items that are firing off their costs. Now, as an option, we can always go back and decide whether or not we would like to consider a rooftop system because we were at 4 stories. So if I go over here and then ask the system to go ahead and consider a rooftop system, all I have to do is type in the number 2. And then as I go to my collections, you'll notice that a rooftop system comes in. And for the most part, there really isn't much savings because we're getting to the, I probably have to ask you, Kurt, since we're getting to 4 stories, we're not really seeing a whole lot of difference between that rooftop system versus that SCUD. Is that correct?
Correct. Yeah. At that point, it becomes a wash, and that's where typically we see, above and beyond that, when we get to more stories, that the scud system is preferred with the condenser water riser rather than large ductwork risers that are going to consume rentable space for the owner.
Right. So the system is working behind the scenes automatically to determine the best, but again, if we don't, we want to see some options, we want to check those, we can go ahead and make the manual overrides, and of course, as we make those manual overrides, we can determine whether or not it makes sense to do so. Now, I'm in the 4-story building and making those changes. I do want to point out, if I went back to either one of the, say, the 2-story or the 1-story, I could certainly do those same types of options. At the moment, the 2-story is electing to be a rooftop system, but I could certainly come in, change the mechanical system, and say, I would like you to be a chiller, simply typing in 1 on the mechanical system, and now the collections that are fired are a chiller. And again, that may not be very cost effective in doing that for a 1-story or a 2-story building. If I go ahead and undo that, I was almost at $1 million, or 900 and some change, and now I'm at 800 and some change. So a little bit more economical to do the rooftop system on a 2-story. Now, one thing that was quite interesting as we were exploring the different types of buildings in different stories is that we found that, again, after a certain threshold of number of stories or square footage, that it just didn't make sense to do a rooftop system. So I'll go ahead and do a demonstration of that, where I'm going to create a 5-story building. All the other options are the same. And as I place my 5-story, in just a moment, I'll navigate over to the tab of the view, and what you'll notice is, just like the 4-story, it will default to a chiller system. So now my 5-story is placed, and as I go into the 5-story, you'll notice that, again, it has been defaulted to the chiller system. And I might have gone down here before, but I do want to point out that the chiller system does have quite a bit of logic in here as well. We see that there's 18 line items of cost. There are certain ones that are not turned on based upon the type of chiller that you're using, whether it's going to be a water-cooled chiller or an air-cooled chiller. The same thing with the heat. Are we going to have electric heat? Are we going to have water heat on here? So certain items of cost do not appear, and that's just based upon whether we have elected to turn those on by default or not. Now, back in my contributing variables, I'm going to go ahead and want to see what's the difference if I changed from the chiller at it's almost $2.3 million. If I go ahead and ask the system to consider a self-contained unit, all I have to do is type in the user-defined variable 0 to turn on self-contained, and then the collections will re-update, and now I can have, again, a savings of about $300,000 at 5 stories if I went to a self-contained. And then, of course, here's the thing that is really quite interesting. As you were seeing that the rooftop units really started to not become economically viable after 4 stories, if I elect to go ahead and say, well, I'd like to see what a rooftop system would do, you'll see, even though I have typed in the number 2, back here in our collections, the rooftop system has still been set to 0, and our self-contained system has still been turned on. And this is one of these kind of safeguards where, if you're not coming from a mechanical background and you're using DProfiler and this database, you may at some point make a little bit of an error, especially if we go up to, say, 10 stories or 12 stories or 15 stories. A rooftop system would not be advisable at all because of just the floor plate area that you're going to be taking by the ductwork. So we've capped it off at 5 stories and the square footage. So nice example of being able to put some logic in place to try to safeguard our clients. Now, it is to be said that if you really, really, really wanted to do a rooftop unit, you could always go back in, and many of you may have taken one of my training classes, you could always go back in and just modify the formula and simply just turn on the system. I would not advise it, obviously, because we have kind of gone through this approach to make sure that we are safeguarding it, but you can always turn on any system if you would like to check that. Now, just to do a couple more demonstrations on this, I'm going to go ahead and start a brand new project from File New. And some items that are also included in the Advanced Logic database, I'm going to go ahead and bring up my PowerPoint presentation and then bring Kurt back in to get some additional comments here, is in the sample database we also provide a template, which I'm going to do in just a second, which allows us to have the cost automatically applied for our soils. It also provides additional custom materials that are above and beyond the 12 base materials that we shipped with the product before. Included in the Advanced Logic database is also a room list dropdown that if you select on the rooms that are in the list, it will automatically apply the cost, whether it's an elevator, a stair, a office, a break room. And then, as you saw before, we do have an office building type and a garage. The garage is both underground, could be below grade or above grade, so there are options just like you saw with choosing the mechanical systems, and whether it's a chiller, a rooftop, or a scud, you can do the same thing by indicating if your garage is above grade or below grade. So back in DProfiler, I select on my custom materials and soils costs so I can start a brand new project. And then, of course, I have the office building and the garage. And I'll simply select on Next. And Kurt, we talked about this a couple weeks ago, that you had a client, or you're looking at a project right now that's about 15 stories.
Correct.
An office building.
Right.
In the Dallas-Fort Worth area. And so we're going to go ahead and create a 15-story building and then select on Finish. And the reason why I'm asking Kurt about this is because you had options, or as you were interfacing with that client, they were asking you questions about chillers versus studs and everything else.
Sure, sure. Yeah, and I'm sure this is nothing new to any of the listeners, but a lot of times when projects come out conceptually, they end up changing numerous times, and budget seems to be one of those driving constraints that's really being affected these days. So we're getting a lot of requests to say, how can we remove some costs from the project so that the project can move forward? So this particular project that we were looking at was 15 stories. It had a chilled water system in it with a chiller in the basement, cooling tower on the roof, air handling units on every floor throughout. So one of the things that we were being asked was, how can we make this project, reduce the budget, the mechanical budget on that project? So the easiest and quickest thing is something that you will now be able to do with your DProfiler, and that's just to take that chilled water system and change that from a chilled water system to a self-contained unit approach, in which case Doug did it on some of the smaller buildings, and you can see there was quite a substantial savings, but on a 15-story building, those savings are magnified. So as Doug runs through that, you'll be able to see what those savings are. But that, along with removing the different sources of heat, let's say if we're calling for boilers and hot water heat, and you want to see what the deduct would be to go to electric heat, you now have the capability to do that within DProfiler rather than going out to your subcontract teams to figure those things out. And these are all just, time and time again, every time a building or a project's over budget, these same variables are what I keep being requested to remove from the project and provide deducts for. And you guys, we've taken that logic and those pricings, and we've integrated it into DProfiler at this point. So now you'll have just a click of a click of your mouse, and you're going to have those answers for your clients.
Fantastic. So I have a 15-story office building. Now the interesting part about this 15-story office building, not only does it have the cost for the mechanical, electric, and the plumbing, this Advanced Logic database is also taking into consideration the elevators, the stairs, and this is a completed project where we're also considering all tenant improvements and finish out. So FF&E and everything is included. So this may be similar to, Kurt, the project that you were kind of chasing as well, where there's a number that we're looking at. So if I go to the estimate view, at this point, just by a simple click of the mouse button saying how many floors using this Advanced Logic database, I see that we have about $63 million of cost in the project. And of course, yours may have been in that same kind of range. And then all of a sudden they're asking you, can we reduce the mechanical? Could we go from a chiller to this scud? And what would that savings be? So let's take a quick look at what that impact would be. Making note that we're not changing anything else other than just one system. We're going to just change the mechanical system. So we're at $63 million at the moment. If we go over to the tabular view, taking a look at our massings tab, and then back to the contributing variables, we're going to ask the system to consider using a self-contained unit. Now, before I do that, I should probably take a look at what is our chiller price. And as I go over to the chiller, we're at $6.8 million. Seems a little bit reasonable. Is that
Absolutely.
Is that correct?
Yep.
If I go over to my contributing variables and change from the chiller system that was the automatic over to a self-contained, I'm going to go ahead and change that to 0. And immediately we have reduced about $700,000 of cost, it looked like.
Mm-hmm.
We're at $6.1 million now. And of course, if I went over to the estimate view, I'm now down to $62.3 million, which overall, of course, that's with fees and burden all in, starts to indicate whether or not this may be a value engineering option that might want to be considered.
Absolutely, yeah. Overall, that dropped about $2 a square foot off of the total building cost.
Yep.
So it had a pretty big impact right away.
Now, you did do this exercise, obviously, for real.
Absolutely.
With the client, and of course, there's probably other value engineering options that they were looking for as well.
Sure.
Does this seem to be on par with what would happen, or
This is typical. This is typical. Every project that's over budget, this is the typical exercise. Additionally to this, if let's say this building was had a hot water boiler system in it, so that means that they're going to distribute hot water to all the air handlers on every floor, and they're also going to distribute hot water to all the terminal units, all the VAV or fan power boxes on the floor. So there's quite a bit of hot water distribution in there. So that is another one that's typically, that's the way it's designed, because energy consumption wise it makes the most sense. And if the builder, if the engineer is doing their job, they're trying to provide the best product for the owner. But a lot of times then when it gets out, it ends up out of budget, and we have to remove some of those options and point out the fact that they are going to sacrifice a little bit on their energy consumption. But we've also built that logic into DProfiler. So if we click and turn on the hot water heat at this point, we'll see what that building would cost us. And then we can also, because right now we have it so that it defaults to electric heat, because we're, again, that fictitious Mason-Dixon line, we're at 27.6 BTUs per square foot in the Dallas market for natural gas consumption to heat a building. The additional, so at that point for us, the first cost associated with putting in a hot water system and a heating system really doesn't have quite as great a payback. So we're defaulting to electric here, and it goes up to, we've made the cutoff on the programming side with this at 40 BTUs per square foot. So if you're typically using 40 or greater BTUs per square foot, yours is going to actually default to a hot water system.
Very good.
So,
now, what you mentioned is that it's probably more efficient to go with a hot water system north of the Mason-Dixon line, and of course, at the same time, possibly supply, because you've got hot water
right.
in the building, you can then supply your VAVs with the hot water as well.
Absolutely.
And that's probably some efficiencies.
Yep.
Now, because we created this cost database here in Dallas, we started putting some defaults in for the Dallas area. One of the options is for the VAVs is to have them electric. So for everyone that is in the northeast, be aware that the heating option at the VAV box at the moment is set to electric, but we can certainly go ahead and put this to 0. Now, here's something that's interesting to do, which is if I set that to 0, before I set it to 0, hold on a second. Let me go back and take just a quick look at the mechanical collection that would be pricing the VAVs, and I believe that is in our common mechanical items. So if I go in here, you'll notice that at the moment, the cost of our VAVs for core and then also for the tenant is going to be 106 plus another 652. So we're about $758,000 in VAV cost, and this is based upon electric. I'll simply go back over to the contributing variables and say I would like to go ahead and option that to hot water. And as I press 0 to then go ahead and send the signal that I would like to have hot water heat for my VAV boxes, as I go to the common, what we'll see is, wait a minute, I still have electric heat. Now, the reason this is the case is because we don't have any hot water in the building at the moment. So again, we've tried to put some kind of belt and suspenders around our logic so that even if you want to have maybe more efficient hot water heating at the VAB, you can go ahead and opt or try to get that, but if you don't actually supply the core element, which would be the boiler, then we're not going to be able to go ahead and price that. Then we don't have a gap. So we can go ahead and I've done it intentionally to let everyone realize that if you do want to click that on, because you might be in the Northwest or the Northeast, and that might be your default, you still have to make sure that you set another parameter or another user-defined variable, which is to turn on the boiler. Now, the way we turn our boiler on is based upon the number of BTUs per square foot. I'll go ahead and try to find BTUs in my list. Probably best if I just sorted by name, and then I could probably find BTU here near the top of the list. By default, we are setting it to Dallas at 27.6. The range is from 20 to 60. And as Kurt had mentioned, if we go north of the Mason-Dixon line, we're going to set it to 40. So I'll go ahead and click on or type in 40. And the moment I do so, a couple of things have happened. As I go back over to my collections, you'll notice that the heating system has now been turned on. And inside of our heating system collection, we are now purchasing items that include the hot water boiler. And of course, we have a couple of additional options that are supporting that boiler. You do have options once you are going north of 40 or from 40 BTUs on up to 60. You have options to also go to a steam boiler, and of course, you can go to connecting to an existing plant that all you need to do is buy the steam for the hot water exchanger. So those are options or variable sets inside of the collection. Now, also interesting to note, because the boiler has its cost on, and it does exist inside of our model, we now know that we are purchasing the boiler. By going back over to our mechanical common items, I would expect to see that our VAV boxes that were electric have been turned off, but in its place, we are now buying VAV boxes that are hot water generating the heat. And so, again, we try the best that we can to try to set up some logic that would help the end user as they are making their selections, that everything has to be in alignment, just like the rooftop units has to they have to be under a certain number of floors. Same thing with the boiler. You have to act, or same with the hot water on the VAV. You have to have that boiler and have to have that additional surcharge of buying the boiler in order to actually have that out to the VAVs. So if I go over to my estimate view, we are buying more heat, or it's going to be a little bit more costly because we had to buy the boilers, so we're up to $64.2 million to go to that build this building somewhere in the north. But it's also important to note we could always do a what-if scenario as well and say, well, rather than maybe having some life cycle efficiencies of going to the hot water all the way out to the VAV, we could go ahead and see what happens if we were to go ahead with electric. And here again, that's just simply a variable that says, well, rather than setting the hot water or setting the heating option of hot water for the VAV, we can go ahead back to electric.
So that's basically going to keep the hot water in the building and serving your primary air handling units, which are using a majority of that hot water. But then what it's going to do is it removes the hot water heat at all the terminal units. So in a building this size, you might have 300-400 terminal units, and all those terminal units would have piping associated, hot water distribution piping associated with that. So by turning this off, it just removes that hot water from the terminal units, not necessarily from the building itself, from the primary system. So what you're going to end up happening is you don't take as big of an energy hit by doing this. It's a VE. It's a way to get some money back into the project, but it doesn't hit you as hard on the energy side of things.
Perfect. And again, we did see the impact that there was a subtraction against the estimate view. Of course, this is a smaller deduct compared to actually changing systems completely. What I'd like to do is turn it over to Kurt for a couple of minutes because I know that we have people from all over the United States, and Brant is in quite a few different regions, and like to give him a little bit of exposure to those that may not have come across Brant before.
Great, thanks, Doug. Brant, we're the largest mechanical, electrical, and plumbing contractor in the state of Texas. We've recently celebrated our 60th birthday this year. We've got quite a bit of projects and historical data that we've been able to and been keeping track of metrics on, and that's what's been given us the ability to pull together a lot of the information that you now see inside the DProfiler database. We've got 2,000 plus employees. We've got 5 offices here in the state of Texas throughout. We're currently working in all adjoining states, so Louisiana, Arkansas, Oklahoma, New Mexico, and Arizona. We're continuously looking at opportunities to expand beyond just the Southwest region here. We operate out of a LEED Gold facility, so we are definitely part of and believe in the sustainability of our projects. We live it, we breathe it, we designed it ourselves. So that's a little bit about Brant, but what really is the horsepower that we've been able to harness from Brant and from some of the metrics that we've been keeping for the past 60 years has really given us the logic and some of the financial costing metrics that we're able to put into DProfiler, so that it gives us, so we feel real confident in the solutions that DProfiler is, or the information that is being put into DProfiler to give us the outputs. The one thing, and I'm going to kind of jump down, we got the new slide up here, but while I'm talking, the dynamic estimation piece is something that we probably want to talk about. On a contracting side of things, mechanical contracting, electrical, plumbing, every time we cost something or take something off, we have a dynamic estimation that goes out to the street for current market pricing. It takes into account the volatility of the commodities, etc. What we have currently in DProfiler is a snapshot pricing. So these databases, and it's regional at that. So the database and the pricing information that you have is not going to be reflective throughout the entire United States or the entire world. So that's something that's going to require periodic maintenance. I would suggest reaching out to your subcontractor community, putting together a spreadsheet or giving them a copy of the database so that they can start plugging in some of their own values for those things. A lot of the items were either unit costed, their square foot costs, their lineal foot costs. It's gotten a lot more complicated from a costing side of things than it was just to say, how much are we paying per square foot for a chilled water system? So periodic maintenance of your database is going to give you the most reliable results, time and time again, and continuing on. If you need any help with that, you can always contact Doug or contact myself, and we can help you steer through any of those things that you need to figure out, or kind of let you know what our thought process was behind and how we got to some of those costs if you need further discussion on any of the individual items.
Perfect. So obviously, Kurt, you and I are going to continue to work on this database, continue to enhance it, add additional functionality. Things such as, at the moment, we have first cost, but we're considering life cycle cost as something to put into the database. We are, as you mentioned, we are tracking, at least here regionally, the installation costs, and of course, adding that, putting that in. Obviously, as you generously suggested, that people could contact you, give you some, maybe you can give them some suggestions, maybe some, even if it's not in the region that you practice. I know that you are looking at, or Brant is looking at, the East Coast and some other areas to go into. As far as building types or projects that interest you, I mean, obviously you go after most things, but
sure.
Some things that actually draw you to a region would be healthcare. I mean,
yeah, absolutely. Yeah, healthcare, data centers. We do quite a bit of work in healthcare data centers. The more complex the project, the more it suits us. The messier and more complicated, I mean, with utilizing BIM and 3D modeling and a lot of those things we're able to do, we like it the more complicated, the more complicated it can be, the better off for us. So
perfect.
And we're looking at some things, there's different ways that we can figure out ways to tie in some energy modeling also to this, and I know we're kind of talking about those things. So Doug and I, the more time we spend together, the more brainstorming we do, and I think the more of those things that are going to end up in DProfiler for the user community.
Definitely. Well, what I'd like to do is open it up to everyone that is online and see if there are any questions directly associated with the Advanced Logic Database or anything else about DProfiler or brand engineering that we could answer for anyone. So go ahead and either type in your comments and we'll go ahead and answer those. It looks like Steve Loneman has a question, and let me just check. Steve, let me unmute you, and we can maybe hear your voice here. Let's see if I can unmute. Or Steve, if you could actually type your question in while I try to figure out how to unmute you on here. Well, I'm not seeing any questions arise. Oops, here's a question. Perfect. All right. Why am I not able to see it? Okay. The question is, the number of VAB boxes for the 15-story building came out to about 20 per floor. This appears to be high for a core and shell building. How are you calculating the quantities of boxes? Excellent question. Now, this is high for a core and shell building, but what is happening here is that we are actually including both the core and shell and the finish out as well. And that is just by default what it is that we have opted here. There is one powerful option, which is to reapply the building type from the database, where I could actually turn off all FF and E. So what I'll do is take the liberty to demonstrate this as more than just the VAB boxes, but the answer to this one is, and you're right, if we were to say that we just wanted to see what the core would be, that we have to take actually 15 floors divided by the 53 to get to the number of VABs per floor. Let me go ahead and, Kurt, you can take a look at that. What I'll do is demonstrate that if I went back to, and I should also point out, my current estimate is at $64.2 million. And that is a fully completed building, all tenant furnished equipment, everything is in place. I'm going to go ahead back to the database and change the FF and E variable, provide FF and E. I'm going to set that to be 0. So by default, I always kind of go with the worst case scenario, which is that we have to provide all of the cost. I simply have to go ahead and say that I do not want to have FF and E included in the price of the project. I did that back in the database because I want to be able to pull that out from the VAB boxes, but I also want to pull out all of the interior finishes that have also been calculated based upon building this building. I simply select on the apply building type, office building, and then back to building, and then I'll say okay. Now, bear in mind as I do this, because I did not change the, actually let me just go back here, because I did not change the BTUs per square foot, then it was automatically going to reset this to not have a boiler. So if I just went back to my BTU, just to make sure that everything is consistent, I can go ahead and set this to be 40 as well. And now this would be an example of just backing out the VAV boxes so that it is on the core shelf, but it's also going to be backing out all of the tenant finish element. So if I select on costing, apply building type, office to my complete project, when I say OK, and this may take maybe a minute or so because it has to do quite a bit of calculating and sending out all that information to all of the building, the floor slabs as well. So I'll go ahead and just check. Yes.
On the regarding once you remove the tenant fit out boxes, we were left with about 3.5 boxes per floor, and those are going to be to take care of your core areas. So you got your restrooms, your elevators, etc. So that'll take care of the core. Beyond that, we haven't really made any provisions for freeze protection out on the floor or cooling because those are kind of regional items. So it's a real good question as far as that goes, because you will have to either think about maybe some unit heaters out in the space or a couple temporary boxes just to provide some temper cooling for if they're not going to complete build out afterward.
Perfect. Thank you, Kurt. And as you notice here, as we pass the system variables or the user-defined variables back into our systems, you will now see that we've reduced from $64.2 million down to $46.8 million. Again, a lot of this is based upon the interior finish out and all the items of cost that are associated with that based upon building a 15-story building. But it does also include, if we went back over to looking at our common mechanical, that the VAV boxes that were electric, because again I kind of defaulted back to electric even though we still have the boiler heat, is anything that is on the tenant finish side has been opted out. Excellent question. I'll just check and ask again if there's additional questions that anyone might want to submit. Please go ahead and type your questions in and we'll repeat them. We have about 8 minutes till 11. If there are no more questions, and again, you can ask a question by raising your hand and then I'll pause and wait for you to type the question in. If there are no more questions, then I'll wrap it up. And this has been recorded, so we'll also be able to post this for those that may not have been able to attend or for others in your work group that may want to watch it later. You can always go ahead and share the video. Since I don't see any hands raising, I'll go ahead and bid everyone a farewell today and hope to see you soon in another webinar.